Thank you, Barbara. Thank you, Mika. My name is Janada. I'm the data flow officer at PTS. And in order to understand the parameters of ICT, information and communication technology, which we would like to distinguish between IT, because IT means something else in OSI, for the rapid deployment of GMO, the Geospatial Information and Management System for OSI, and EMO, which is the Equipment and Implementation Management System for OSI, we need to look at the constraints of the treaty. A couple of things I would like to note is that we are limited to 40 inspectors. The ICT equipment must be ready in the ready state, so blank database, no data available, and also the ICT equipment is also air-gapped and is rugged under field conditions. So, looking at the events that took place, the earliest system is FIMS, which is the Field Information Management System, and IIMS, which is the Inspection Information Management System, I believe. I forgot that. And these were used during the integrated field exercise in 2014. The other thing also is that after the IFE 14, there was a plan in place, an action plan in paper 1343 that took the lessons learned from IFE 14 and brought it to the next level. Important to note about IMS is that it did actually implement the inspection field inspection team functionality for the first time. Now, from this point on, we're looking at the tabletop exercises that used the GMO as well, and also every other event that we've had, exercises, training, we also used GMO as well. So there's a full, we give the inspection team or the trainees multiple opportunities to use GMO. So in a sense, we have also the directed exercises in 2023, and also the built-up exercise in 2024. So this slide is a little bit busy, but wanted to spend a little bit more time in this so that we can actually look at how GMO has evolved. So this is a Wayback Machine. So recalling all of the technologies that have evolved. So it doesn't necessarily provide the exact dates, but in terms of the concepts that may have actually, some of the concepts have been back in the 1970s. But this timeline outlines the ubiquity of ICT progress in our minds. Starting with network bandwidth, if you think of what the network bandwidth was back in the day, it was 10 base T, dial-up, et cetera, and as we come to today, we have now gigabits, I guess, more than 2.5. Somehow, at some point, we have 10. So we have, and it's continuing to grow. I wanted to also look at the visualization aspects. This is a key importance of how GMO is being used in the field. And in 2007, that's when a lot of the computers started to become virtualized. Virtualized. And in around that time is the EXXI, which is like the bare bones operating system for virtualization, along with cloud computing, and I'm sure everyone knows AWS, Amazon, whatever services. I forget what the terminology is, but I also wanted to touch on the point of containerization, which is Docker and Kubernetes. And that's also another level of abstraction, decoupling of operating system with hardware, decoupling of software with operating system, et cetera, et cetera. I also wanted to point out some of the programming advances. For example, I put VB6 in here, and why I put VB6 in here is because this catapulted homegrown programmers, and this continued to evolve into .NET, and I guess the major advancement was in 2010, around 2010, Node.js, REST, HTML5, JSON, processing as a service, software as a service. In this slide, I also put in CTBT. Why is this important? Well, it's actually in an area which is rich in ICT. However, we can see that in the CTBT, there is a discussion, or there's a line mentioning about still photography, and as we know today, everyone has digital photography. This is interesting because now the CTBT is actually frozen in time, and we have all these advancements in ICT, and we have including greater than 1 gigabyte, 4 gigabytes of imagery, which used to take 15 minutes to load on a single computer. We have social media, crowdsourcing, streaming services, you name it, smartphones. So the landscape is continually changing and evolving, and for us, GMO also needs to continually evolve. And I wanted to actually point out some of the geospatial, from a geospatial perspective, the major disruptors. For example, Google Maps. Prior to that, it was probably not as interactive as one may seem, but the importance of displaying the world in WebMercator as well, and also OpenStreetMap. So I'm looking back at the IFE. I'm not going to spend too much time on this, but IFE is basic. If you look at the pictures there, it's one person there. The tents are separated. It was only use of FIMS, and what FIMS is actually just a glorified geospatial application which gathered all the information, but then provided the information to the inspection team leader. In 2014, what one can see in this picture is that the working area tents are now combined together. There is an IIMS, which is for report writing. The computers are now networked together, and we're using, in this case, which I haven't been privy to be in the IFE, but from what I know, it's a virtualized environment, and it's completely networked. And now I want to discuss the current infrastructure. It's relatively the same. There was one new aspect, which is the highly protected working area. So in the past IFE, there was no highly protected working area. It's now co-located in the receiving area behind a screen, and it's actually under joint custody between the inspection team and the ISP. Important to note about the Geospatial Information Management System is that it's GMO is is the siege machine against against personal biases, and it actually incorporates the inspection team, or embodies the inspection team functionality. We also have integration with the Operations Support Center, along with zero clients, centralized, and centralized data storage. So let's say, for instance, someone is ill, then someone else can take over that job and enroll. Now, looking into the architecture of what GMO is, we are using Docker. And what it is just multiple virtual machines that integrate, or that run the program, the application GMO. And now we can actually deploy it multiple times. This is where I'm coming to, is the ability to deploy multiple GMOs in different varieties, in different flavors, has different functionality. It's accessible. We give it, and it has quite a bit of security, integration of data, and it's good for archival and backup. Now, the drawbacks is that it's many environments, it's complex, the virtual machines can run out of memory, and it's tedious to log into every virtual machine to manage. Now, in the future, what we would like to do is to use Kubernetes. What is difference between Kubernetes and Docker is that the container for storage is outside of the virtual machine, no longer have the virtual machine. So this is where we can have a better mechanism for archival, and there's a better mechanism to actually deploy an archived system in the future, or for access, as we discussed in a previous session here in S&T. And that's my presentation.
So, thank you very much, Jonetta, for giving us this insight on the GMO and EMO. So I see in the audience many inspection team members and the full inspection team leadership. So I expect now a very interesting discussion with questions and comments about the current status of development compared to the past, and especially about your forecasted future developments. Thank you very much.
I must have answered all your questions.
Thank you, sure. Andrei.
Sure. Thank you, Jonetta, for the second presentation and the way you describe how you capitalize on recent advances in ICT for rapid deployment and maintenance. Would you be able to comment also on the cybersecurity dimension of the issue? How novel ways of Kubernetes, Docker, etc., and the plans for the future OSI activities, how you're going to capitalize on the recent technological advances to make the infrastructure also more secure?
Well, actually, thanks for that question. There are a couple of mechanisms. First of all, I mean, we do have the air gap environment, but in actuality, one can actually, there could be potential risks with actual inspectors themselves that could compromise the system. So there are mechanisms in place, especially with Kubernetes, because now one no longer has a virtual machine to log into. So there are other security mechanisms for this. It's not. I couldn't tell you the details of that, but I'm sure there's plenty of security protocols, especially for Kubernetes or even Docker.
Matthias Saldener, please.
Thank you, and I really like the slide of, for us been here since IFE in the 90s. It's really nice to see these disruptive technologies that come and change the way we think about still photography. You mentioned artificial intelligence on the end of your slide. Do you foresee any disruptive things with GMO, that it will be able to plan things, speed things up, make the ITF easier for the IT and the ITL?
Thanks for your question, Matthias. Is it Matthias? Sorry.
Yes.
Yeah, sorry. I know that this is a point, but we haven't discussed that here in this particular slide. I believe it could help. However, I still believe that the inspectors have to verify what they're actually, what the processing and analysis is. There's far-reaching implications for AI to be incorporated into an OSI, and that is a discussion between Working Group B, perhaps a tabletop exercise, and that will extend long into for many years. So I'm not sure I could answer that question for you, but it could potentially be useful in a sense.
Thank you very much for this interesting answer to this very interesting question, which is also, I would say, very well connected to something really important you mentioned about the role of enhancing our tools for regarding personal biases. So thank you very much. Any other question? We have time for one more question, if any.